Learning stuff about JavaScript,
Yeah.
real stuff.
Learning how to get into the building. Did you
Oh,
see my email earlier? Sent you an email
I
like,
still
Sam,
haven't
how do I get in? Like,
oh, you got
Can
here
you do it?
earlier than you got here before.
when they opened the door.
Yeah.
So I'm sitting there looking at the call button. I'm like, this is a unique piece of technology. And then a guy finally comes up and he puts his fob right there. I was like, I was going to do that.
Do you have a fob?
Yeah.
Okay.
Yeah.
I'm still waiting on mine.
Tucker said,
I talked to Ben and he said he sent an email and then I should get it today, but I don't know, we'll see.
we'll see. All right.
Oh, that's tricky.
Oh, Ben will join when he joins. All right, so we're gonna go through that same Git flow process today. So keep getting us familiar with that. So I'm gonna go into our internship classes directory. I'm gonna go.
I have a question.
Yep.
About Git.
Mm-hmm.
So when I navigate to where I'm at in my terminal, where my project is, and then I Git clone my specific. This is the lowest level of the Git tree. So then it'd be Sky within the individual projects. All within Sky within the individual projects. I clone that, and it comes up in my local directory as a folder for Sky that contains a README. But why wouldn't it just be the README? Why is that leveling of...
Why does it get the folder too?
The folder.
Yeah, because that's just how Git clone works. So Git clone, when you do it, it pulls down the folder and all of its contents, including the .git hidden directory, which is what's really important.
Right.
Yeah. So the other way to do it, if you wanted to... I mean, I don't know why you would want to do this necessarily, but if you really wanted to, you could. Here, we'll do it.
And I need to be within the directory that contains that .git to let the computer know I'm in a Git repository, correct?
Yeah. So I'll show you. So here, we'll do if else is going to be our new repo. Public. Which else is going to be? All right, so because I initialized it with the README, it doesn't tell me, but otherwise it actually gives you all the examples of how you can do this. Let me just create a new project so you can see that. Nope, dang it. Okay, so yeah, if you initialize it without a README, it tells you how to do these things. So it says, hey, make sure your Git global setup is set up. You guys have already done that. And it says, okay, now there's several different ways that you can pull this thing down. The first way is that you can create a new repository, which is to say, I don't have a directory there yet, right? And so I want to get one. And this is what you were talking about. When you do git clone, it's going to pull down if else 3, make that a directory, and then inside of that it's going to have a bunch of stuff. Second option, you already have an existing folder, right? You already started working on it locally and you want to do something with it. In that case, you need to cd into the existing folder. You do git init, that creates that hidden .git directory. You do git remote add origin, the ssh sha, and then you do the gpush command, is what these 3 things are. Okay. So you can do it that way, but
gpush, yeah.
So when you want to do something like this, is like you generate your Rails project or your Stencil project locally, and then you want to push it up and to get started instead of. Yeah. So like we can do that today for our if else. So I'll pretend like I've created a Stencil repo. I'm going to create a directory called if else and then I'm going to cd into that, and then I'm going to do get init, get remote at origin.
Of the clone thing.
And then the clone thing. So you go into here and you click clone, and then the SSH.
And then now we should.
And then now, yeah, you could get push. And then if you do a -u, it sets the upstream.
What's that?
It just says when I do get pull or get push, I'm referencing the remote master.
Okay.
It'll just give you it'll tell you to do that if you don't do that, so it doesn't really matter. You just have to read. So that's one of the things, like early on in development, a lot of times you don't read the crazy output that comes out, and to some extent you have to learn when it matters and when it doesn't. Oftentimes it is useful to read what it's saying. I can't push because most likely, yeah, it's probably got a lock on master.
Okay.
So let me just start by pulling. It's probably a good idea anyway. Jeez.
Why did you copy the error with it?
I don't know, something weird happened.
The buffer didn't clear fast enough.
Oh, hold on. There,
Think too fast.
Yeah. Well, my tab button's supposed to autocomplete, but we don't have a local version of the Git repository yet, so it can't autocomplete. So normally I'll have to type as MA tab enter, and it's just not there. So, but now I should be able to push. Yeah. So I just had to pull first, and then I could push.
Alright, but if you pull first, it's going to overwrite everything over, correct? No?
Mm-mm.
It's going to pull down the changes?
So there's several different ways that things can happen. If you tried to pull and you hadn't committed anything yet, it's going to tell you can't pull because you haven't committed anything yet. Mm-hmm. Once you add your commits in, then when you do the pull, it's going to say, oh, I've got some conflicts going on here because you've got a README, they've got a README. Let's figure that stuff out, which is totally fine. If there's no README, then there's not going to be any conflicts, and there won't be any commits, and you'll have the first commit and you can push it. Okay. So it works out, and like the errors that you run into will be obvious what's happening.
In so terms you still, of bits, so anytime you go from you switch from local to remote or remote to local, those are probably going to be the times you're going to have your conflicts. They need to get solved.
Yeah.
Or no, it'd be on this merge.
It's you. Ideally, the merge. Yeah, where you should have conflicts either here when you're merging remote into remote, or here when you're merging master into your local branch. If you get a merge conflict here or here, you've done something wrong. Like most likely, if you get a merge conflict here, you've added commits to master instead of doing them on your branch and then pushing them to remote and then putting them on the remote master. Okay. So there's something about something you did that caused an issue. You should only see merge conflicts happening when you're doing a merge, so that says merge. Okay. All right. Cool.
Yeah.
So let's get into real stuff. All right. So I want to start doing some JavaScript things. We're going to be talking about if-else today. So what do I need to do to get started?
Oh, definitely start always your own branch.
Yep. So create our own branch. And then what else do I, so now how do I actually get coding?
You got your own branch.
Got my own branch. Document. Yeah, what document do I need?
Oh, we're doing JS.
JavaScript?
Yes.
Yep, so what do I?
Left click, new file, JS file.
Yeah, so we can have an app.js, whatever. Yep, and then what else do I need to make this actually run?
On the web HTML.
index. HTML. You need an HTML file. Yep. Index.html. All right. So I got my index.html file. So now how do I, like it's still, if I go open up this index.html, what's going to happen?
It's gonna be nothing.
Nothing. Why is there going to be nothing?
You didn't code anything.
I didn't code it. I mean, that's true. So how do I make something? I just want to see I just want to print out hello world in the console.
Basic HTML. Get your header, your HTML formatters, right? So like your
tags.
type, your head and your body. And
Yep.
you can throw in your hello world in your body.
Yeah, so I could put hello world in here, but I want to see it in the console, like in the JavaScript console.
Console.log.
Where do I put it though? So if I do console.log hello world here, what's going to happen?
We'll probably get like an error. Or no, it's just going to put that as text.
It's just going to put that as text in the body. Yeah, see that? What are we missing?
Not in the console.
Oh, we didn't embed the JS file.
Yeah, we didn't embed the JS file. Yep. So where do we embed the JS file?
In the head. Script tag.
Yep. In the script tag in the head. Yep. Script source equals app.js. Okay. So now what's going to happen?
Hopefully it works.
Hopefully it
Let's
works.
try.
All right, yeah, let's try. It's the same thing.
Okay.
So what's going on?
What else are we missing?
Oh, isn't it supposed to be in the JS file?
This is supposed to be in the JS file. Yep. So yeah, I'm letting you fail just so that you can learn the lessons about these things. That's all. All right. So yeah, we're gonna take that. So that's JavaScript. The only thing you put in HTML is HTML.
Text.
That's JavaScript. So we have to put it in into the JavaScript file that we're referencing. So now it knows to interpret it as JavaScript, and so now when we run it, we get hello world. Cool. All right. Can somebody tell me what variables are again? Like, what's the definition of variables in programming? A value that's being assigned. Yep. There's a synonym for variables that we.
I'm gonna use what was a better one than renaming?
Okay, but that's close. Alias. Yeah. Okay. So renaming alias is just another way of referencing the same thing. Okay. Just a pointer back to what it used to be. In many cases, it's literally a pointer to someplace in the computer memory. Okay. There's different data types we talked about last time. So what were some of the data types we talked about?
Strings.
Integers.
Got arrays in.
What was that?
Arrays. We even got objects.
Objects.
Like Boolean.
Booleans was the last thing. And that's where we're going to start today, is with Boolean operators, if-else statements. All right. So there's several different ways that you can structure your code for branching purposes. So we're getting into creating decision trees. Okay, we're trying to tell the computer that if one thing is true, then go this way. If it's not true, then go the other way. And this is largely how computers work behind the scenes anyway. This is why they're all ones and zeros. It's just making a bunch of decisions on, should I go left or should I go right? Okay, should I go up or should I go down? And so what if-else statements allow us to do is exactly that. Now there's different types of if-else statements. There's case statements or switch statements they're called, which are ways of creating like multiple tiered versions of if-else statements. But you can do everything with if-else. We're going to largely stick with if-else. If you have more than 3 branches of an if-else statement, you probably are doing something wrong. You probably need to start creating more methods. So we're going to stick with that simple case and say that that's what we're gonna have most of the time.
Okay.
So if I say, let's say I create a variable called direction.
Do we not use let? Or
I'm going to set a constant at the top. You could totally use let. I'm going to set a constant at the top of the file and never change it. This is just going to be our, like, when we run the code, I'm going to change this to be north, south, east, or west. So it's going to be a constant. We're never going to change it in the code itself, and so that's what I'm doing. But yeah, you could totally use let. Okay. So I want to write some code where if direction is north, I print north. If it's south, if direction is S, I print south. If direction is N, I print north. If direction is E, I print east. If direction is W, I print west. Okay, so for example, if I do something like that, I expect that I'm going to print west.
Should we stick with if else, or you can use all of our if else tools?
Let's just stick with if else.
Okay. Well, yeah.
And you can use else if, but yeah.
So if direction triple equals.
Yeah, triple equals y triple equals.
And then
y triple equals.
Y triple.
Yeah, y
triple.
not.
Oh,
yeah,
because
y.
we're testing for literal equality.
Yep.
All of our directions. So north, we can go in first, and then if that's that, we want to print north. So
we're just gonna console
brackets. Yeah.
Okay.
And else if under that. Direction is equal to south or S. And then we'll print south.
Yep. Direction equals east, then we print east, right? And then if it's west, we print west. All right. So if we were to run this code right now, what's going to happen?
Look at.
It's going to print. It's closed. It's going to print west. So if we follow direction, right, we're going to say reading JavaScript all the way down. We go from line 1 down. We're going to start with line 1 says we're going to set direction equal to W. Line 3 is going to say if direction is N, is direction N?
No.
Nope. So it's going to skip down to the next if statement. It's going to say if direction is S, is direction S?
Not true.
Nope. So then it's going to skip down to is direction E? Is direction E?
Not true.
No.
And then it's going to say is direction W, and is direction W?
True.
Yes. So then we're going to go inside of the braces, and we're going to do whatever inside of those braces. In our case, it's console log west. Does that make sense?
Mm-hmm.
Okay. All right. So there's some interesting things here. What if I do that?
What if you do?
It'll give false.
You run this code.
But what's going to happen like in my console on my web page?
Would it go through like all of them and find no R's and so return false?
It will not return anything. So the way that we've written this, it's what's called a void function. Mm-hmm. So there is no actual function. We're just executing at the window global level. Mm-hmm. We'll get into what that means and how to deal with that later. But there's no return in JavaScript. You have to have an explicit return. Mm-hmm. We're not returning anything, so it's just going to do nothing. So the computer will evaluate each one of these one at a time. So it'll take some time to do that, but it's like 1 nanosecond or whatever. But it won't actually console log anything out because it doesn't evaluate true for anything. So how do we deal with this case where, oh, accidentally directions R and I didn't realize that R was a possibility? So imagine, right, like this is a very contrived example, but imagine you hit Rotten Tomatoes and you expected that there were 4 directions that a film could have been in, north, south, east, and west. But now they've added northeast, southeast, southwest, etc. And so your code isn't looking for that. So how would you have any idea what was going wrong with your code? What could we do here to make our lives easier?
To try to catch the condition of northeast?
Yeah.
The else.
An else statement, which is just if none of the other ones catch, then let's go into else, and then we could do something like console.error. So we've used a log a lot. There's console.error, console.info, console.warn. They just make things different colors and stuff inside of the terminal, where we could say unmatched direction, and then we could print it so we know what it was. So now if we run that, we get unmatched direction northeast. Okay. And then because it's an error, if we get some additional debugging, that helps a little bit, and that'll take us to where the problem is. Okay. What if I do something like this?
Just capitalize.
Yeah.
I would imagine it would not. It would print unmatched direction because those are 2 different characters and they're case sensitive.
Because it's case sensitive, yeah. So it is case sensitive. So we're gonna get unmatched direction S. So how could we improve our code to be able to deal with S or S or S?
So you could. All right, so saying because there's more of the else if block and all those are under case, whatever the input we have a constant now. I don't know if we could 2 lowercase that.
You can't. Well, so
Use
you could use or. So you could use or. That is like the first solution, which would be something like this. But I don't like to type things. Is the only real. So like when you're coding, we're gonna get into this. One of the principles that has been tried and true that you want to try to adhere to, and this is totally fine. It works, right? Like again, the thing that we're trying to do is make something work. So this works. It's great. It's awesome. Like that is the most important thing. That's 80% of the way there. If you go a little bit further, your next big hurdle is how do I write less code? And it's not because the person who's writing it is allowed to be lazy. It's so that the person who's coming behind them to read it has a simpler set of code that they're reading through. Okay? So like if I read this, I have to go, oh, if direction is S or if direction is capital S, that's a lot for me to think about, right? So to write a little bit less code is what we're going to try to accomplish. Because basically, like all of these characters are exactly the same. And whenever you see a bunch of characters that are exactly the same, there's probably a way to dry it up. It's called don't repeat yourself. There's probably a way to make it smaller. So how might we do, so this would totally work. It's good. How would we do, what's another way to do this? Sky, I think you're on to something.
Yeah, you could group it just like math. So you could get the S and the S.
Yep.
And you can put those in the parentheses by itself so they're evaluated together. So after the small s, you could put a parenthesis before the small s. All right, then we'll go after, and then we'll have an or sign, and then we'll put the big S.
I don't know if that's.
It's an interesting idea. When I first started coding, I thought you could do something like this, and it would make things a lot nicer in many cases. It doesn't quite work. I'll show you a way to do what you're trying to do. What's going to happen here if we try to evaluate this is the same order of operation stuff that we had to do in math, right? Mm-hmm. So if you imagine, what is the JavaScript? Let me try to do it this way. Because I think it'll help. So all I'm doing is the evaluation of what this piece of code is. So what would S be right here?
Oh,
I have no idea. Go ahead.
I was gonna say it's gonna be like true, I think, because like a string is like
'Cause it's a
truthy or
thing.
whatever.
Kind of. So the way JavaScript, this is actually a very useful thing to understand because this is in a lot of languages, and it becomes useful for doing certain things like having a default or moving. Or operators, the way that they work is as soon as it hits a valid case, it stops evaluating anything after it.
Yes.
So S is a truthy value. We've talked about that before. So it's going to say S equals, and then S is a truthy value, so S equals S. And then it's going to say, well, and S is a truthy value, so I'm not going to evaluate any of this.
Mm-hmm. Sure.
So it's this is the same as writing this. Okay?
Understood.
And I'm going to prove that just so you can see it. And then we're going to talk about another example. So you can see right there, it's lowercase s.
What if you put the uppercase S first and then the lowercase s?
Same thing.
What do you think's going to happen?
Same thing. Same thing, because it's still a truthy value.
So what's it gonna print?
The bigger S, because the big S is going to be something truthful, and then it's going to short circuit and forget about the rest.
Yep, exactly. Because it came before the or operator. So what if I do something like, just to be very explicit, what if I do that?
Well, you know you got to evaluate the other side. You're forcing the computer to evaluate the rest of it, so it's going to equal S.
So then it's going to equal S. It's going to print out the lowercase s. You guys see that? So this is useful for times when you're bringing in a variable and you don't know if the variable was defined or not. And so you might do something like, if it's defined, then set my variable equal to whatever it is. Otherwise, set it to some default. So for example, I might do something like first name equals undefined. And then I might do something like person equals so what do you think that's going to do? Got a little bit more complicated because we put it in an object, but
So you should get Sam Birk.
you should get, just be more explicit.
Oh, so you should get a object with two attributes, and the first name is going to be Sam, and the other attribute, last name is going to be Birk.
That's right. Okay, so let me try to simplify it a little bit. What is first name 2 going to be? So let's think about this for a second. So first, variables are what again? Aliases. So that means I can literally replace whatever the variable is with what was assigned to it previously. So what could I replace first name with? Yep, undefined. So we could do that. Is undefined truthy, or falsy? It's falsy. Okay. So that being true, this is the same, more or less, as this. So what would first name 2 be in that case? Sam. First name 2, yeah, it's going to be Sam. So if I put undefined there, now what's first name 2 going to be? Or undefined and false are basically the same. So it's going to be Sam still. So now I put first name there, which is just an alias for undefined. So what's first name 2 going to be?
Sam.
Yep, Sam. Yep, no changes, right? So first name is undefined, so I could literally replace it with undefined. Undefined is falsy, so I could literally just do that. So first name 2 is false. Well, false is false, so I'm going to evaluate the second half of my or statement. Sam is truthy, so first name 2 equals Sam. Does that make sense? Now it's a little like, but it helps later when you're like writing things and you want to put the default in and that type of thing. So there's usefulness to it. Okay, so back to our original example then.
Yes. How do we
So direction here, remember, we can create aliases, right? So just to make things a little bit simpler, constant south directions. Just as a point, I'm capitalizing these constants because it's just a convention. Constants that actually don't change or aren't intended to change are frequently written with capital letters. Most of the time in JavaScript you're not going to do it this way, but I just wanted to give you guys that's what that is. So it doesn't matter. I could have just as easily written it as. But what you can't do, and RubyMine helps you, this thing and this thing are not the same. Okay. Case sensitivity matters. Okay. But if I do something like that, what is south directions?
Oh, what is south direction?
Yeah.
It should be a bool.
If I console log out south directions here, what am I going to get?
Hopefully true.
Oh, you'll get the
Not true.
small s.
The small s.
Okay.
Remember, what's going to happen? The or operator is just deciding whether it should go to the right of itself or not, and it makes that decision based on whether this is a truthy value or a falsy value. Okay, so if this is truthy, then this goes away. In other words, south directions is just being set to this. Okay. If the left-hand side of the or operator is falsy, so if it's false, then it does continue to the second operator. In other words, it's the same as this. Okay. So in the case where we have lowercase s or uppercase s, what is south directions? Lowercase s. Okay, because it's going to say that's truthy, so ignore everything after me. I don't need to worry about that or stuff. So it's the same thing as south directions equals lowercase s. If lowercase s instead was undefined, then it would just be uppercase s. Okay. So given that south directions is lowercase s, what is going to happen when we run this code?
Unmatched direction.
Unmatched direction, why?
Because our original input, or what we're testing against, direction,
Yep.
is a capital S,
Yep.
and that does not match with the lowercase s.
Okay. You guys see that? Okay. So then remember that variables, again, are just aliases. So I can copy and paste from whatever it was assigned to and put it in the place where the variable is. And this is important. We're doing this a bunch, but it's important because it helps you to see what's happening. Because what you should be seeing when you're looking at the matrix, right, is the woman in the red dress. And the way that we get there is by taking, in your mind, you mentally manipulate and you say, okay, if south directions is equal to that, then I can just replace anywhere south directions is with that. And that's what I should get as a result. So in our case, then south directions is this. The evaluation of this is lowercase s. Direction doesn't equal lowercase s, it equals uppercase s. So we never go into that block and we move on to the final else statement. You guys follow all that? The relatively complex stuff, but it's incredibly good to start to get into. Okay. It's like the mind melting things that you need to like really be a programmer. Cool. All right. So that doesn't work.
Right.
What you were trying to do, we can accomplish in a different way. We'll create, frequently you can create an array of the things that you want to evaluate. And then you can say dot includes. Okay. So what this is saying is,
Array right there.
yeah, because you don't have to do typing. So in this case, what we're doing is we're saying, does direction exist in here? And will it? Because it's uppercase S is one of the items of the array, so it'll go into south. Okay, so that's what you were trying to do.
That's dope. I've never seen that.
Yeah. Includes is a relatively new JavaScript thing, but it works great. All right. So that is definitely better, but we could make this even less code. What's a way to make this less code? Sky, you were on it like early on.
Switch statement.
Nope, after that.
I was on it.
You were. Yeah, Logan, you think you
Converted
converted
to lowercase.
to lowercase. Yep, you said it, Sky. All right, so if we say now that's probably still more lines of code than we need, but one of the ways that we could deal with this is say the lowercase direction equals direction dot to lowercase. And then instead of evaluating direction dot lowercase equals, we can just do that. Does that make sense?
Mm-hmm.
Now this is actually a pretty good opportunity for switch statements in that you're really just evaluating whether a specific variable matches one of certain things, and depending on what it is, you're going to go one direction or another. This is actually a relatively rare thing to run into in practice. So even in this case, I would recommend, it's far more readable to just write the if and the else if statements, because you can then read directly in line what this should be evaluating to. Whereas with the switch statement, it's going to look something more like, I make these so infrequently. Switch case do. I always forget.
Switch and then parentheses and then cases with colons.
Yeah. So the equivalent of this would be
What's switching?
so I'm give me 1 second, it'll make more sense.
break. Because if you don't, it'll just go through the rest.
Okay. So lines 15 onward are exactly the same as lines 3 through 13 in terms of what they do. It's just a different syntax for writing essentially the same thing. The advantage of a switch station is when you're trying to evaluate the value of a particular variable, especially if that variable is an integer or a string, for each case statement you write less, generally speaking. But you do always have to put break, which is annoying. And when you have a lot of these, which is a typical case for using switch statements, you forget, right? Like you can imagine, you can see how very quickly I no longer know what the reference variable is, where that's not true when I'm here. Does that make sense? So I don't use switch statements ever, but it's good to know that they exist. Okay. Questions about any of that so far?
No.
All right. The next thing that you're going to want to do is you're going to say, okay, if so here let's go through this is an interesting exercise. I want to depending on the direction, let's see. Let's do something a little more complicated. All right, and then so this is a relatively complicated puzzle. So try to get some. Imagine that there's a map. Okay, and this position is so x, y. This is position 0, 0, and then we would imagine basic graph paper stuff. And so this would be position x of 1, or x of 2, y of 1, right? Etc. You guys see how that's happening? Okay. So now imagine I'm going to land. The typical example that we use for this is actually Thor. So Thor comes down out of the sky on his rainbow glider, or wherever it is, and he ends up somewhere on this map. He doesn't know where he's going to end up, but he's somewhere. And his hammer went down before him, and they got separated. So his hammer ended up somewhere else. And so imagine, like, maybe Thor ends up here, his hammer ends up here, or maybe the hammer ends up here, Thor ends up here. But he has to get, now we have to move him from wherever he lands to wherever his hammer is. Okay. So the idea is we're going to try and move wherever Thor is, my position, to wherever the treasure is. Okay. We want to do that as efficiently as possible. Now, if this is a map, right, we can say north, south, east, and west. Okay. And what we're going to do is we're going to take one step at a time. Okay? So essentially, we are going to move either from here to here, or from here to here, or from here to here. Okay, so it's one step at a time. That makes sense? Mm-hmm. the way that we're going to decide, or the way that we're going to tell the program to take the step is that we're going to log out, is that we're actually going to move our position one step at a time, so we can increase X and we can increase Y by exactly 1 on each iteration. Okay? So if I start, just to give you guys a full example here, let's say that this is Thor's position, so he's at X of 1, Y of 1, and maybe the hammer is over here, which has an X of 1, or an X of 1, 2, 3, Y of 1. Okay. So we want to move from here to here, right? So on step 1, what's my most efficient way? So like we're on step 1, what's my most efficient first step to take?
To the west.
1 step to the west, right? And then on my second step, what's my most efficient step? 1 more step to the west. Right? Okay. Now if the hammer is here, what's my most efficient step to take? So you really want to go, so I want to increase X by 1 and Y by 1.
Does that count as 2 steps?
Nope, 1 step. So we can make 1 step straight across if we want to diagonally. And then what's my most efficient next step? Okay. And if we do the same thing, let's say I start in the same position, so I'm here, but I want to get to that X. My most efficient first step is, what's that? Still diagonal? Yeah. So increase X by 1, increase Y by 1. And then the next one is, let's do it again. Do it again. And then my next most efficient step is was. Okay. Now, the way that we're going to do this is we're going to log out what the steps would be. So on the first step, I want to log out northwest, which is represented by NW. Okay. I'm going to go from here to here, so I'm going to log out NW. And then I want to go from here to here, again it's NW, and then from here it's just west. Okay. So on each iteration of the loop, I want to define the direction that I want to take, and you can imagine that the program is going to take care of moving the X's and the Y's appropriately. Okay, so you don't have to worry about moving the X and the Y there. You just need to know where you started from, and then based on where you started from, you need to determine if you need to move north, south, east, west, northeast, southeast, southwest, etc. Does that make sense? Mm-hmm. Right. So I'm just going to create a little loop. All right, so we'll say that we have a like 5 by 5 grid, so it's a relatively small. Grid, and then we have 10 steps to get to the hammer. Okay, so we have 10 steps to get to the hammer. We have a grid that's 5 by 5. We need to figure out, based on where my starting position is, what I would need to log out to be able to get to the correct position. Okay, to get to my hammer. How do I get from my position to the treasure? Okay, so what's the first thing so how do we do that? How do we console log out on each one of these steps the right step to take next? So let's just start with the very first step. So let's imagine that this is where we're starting. So X is 0, Y is 0, so I'm at the very bottom left corner of the map. My treasure's position is X of 5, Y of 0, so it's at the very right corner, bottom right corner of the map. So what do I need to do to take the first step? What's my first step going to be? It's going to be to the west. How do I tell the computer to figure that out? So but first, how does the computer even know that it needs to go west?
Well, if you get X
So it's more so the my position is never going to change, and the treasure position is never going to change. The my position actually is going to change. We're going to increase that one to get there. But the first thing that I need to know when I'm talking to the computer, when I'm writing a program for the computer, is it needs to know how to figure out whether it needs to go north, south, east, or west. So you know we need to go west because you can look there and you're like, duh, I've done maps before. But the computer knows nothing. It knows nothing about that. So how does the computer figure out I need to move west? You have these variables.
Test the coordinates.
What's that?
You can test the coordinates. So if you know that the treasure's X position is greater than your current position, then you need to go west.
Yeah, right? If the treasure position X is greater than my position X, then I need to go west. Okay. Now I'm gonna write some functions to make it actually do this. You don't need to worry about it so much. So I'm gonna create a function called move, and it's gonna take in a direction, and it's gonna say if the direction is west, then the treasure position will never change, my position will. My position dot X.
I like the syntax. What's this?
It's ES6. It's like a new version of JavaScript where you can define functions that way.
That's cool.
Yeah, it's much shorter syntax. This is how TypeScript does it too. So you guys are gonna write things more this way. TypeScript's a little bit easier because
TypeScript is a super class of all this.
Yeah, so TypeScript will do that, which is even nicer, but this is the ES6 version of it. This is the same as if you're used to vanilla JavaScript, it looks like this. I'm more than happy to write it that way, or we can even just, there's reasons to do that, but we haven't gotten to functions yet. That's what I was saying about you don't really need to pay attention to this. I'm just going to make it actually do.
Sorry.
No, it's okay. Yeah. Okay. So.
I have just a side question real quick.
Yep.
If you type TypeScript in a JS file, because it compiles to just JS, will it work?
Nope. So the compiling happens during a compilation phase prior to runtime.
Mm-hmm.
So the compiler only ever works like before the code runs. Mm-hmm. So you can't put TypeScript in a JavaScript file, and even if you wrote TypeScript all over the place, if you don't have a TypeScript compiler, it doesn't do anything. Everything's just going to break. Okay. All right, but so we have this function called move that I'm writing for you that's going to do the right things. It right now, I mean, just so you can follow along, it's saying that if my move direction, if you put in to move west, I'm going to update the my position to the my position's x coordinate to have one more. Okay, so plus plus is the same as equals my position dot x plus 1. Okay. We can do it that way if you want to read it that way. But you guys don't need to pay attention to this so much. You need to pay attention to the stuff down here. Okay.
Can you think of the for?
Yep. I can do that too. Also for this exercise, you can not have to worry about that. But so this is just saying, start with I equal to 0. So long as I is less than 10, keep doing this thing. After each iteration of the loop, add 1 to I. So it's going to go through 1. I is going to be 1, and then 2, and then 3, and then 4, and then 5, and then 6, and then 7, and then 8, and then 9, and then it's going to exit out. What it's going to do is for each time that I is updating, for each one of those iterations of the loop, it's going to run everything between the curly braces. So we haven't quite gotten to loops. So again, I'm not that concerned about that. Where I want you to focus is between lines 13 and 16 and line 10 and 11. So those are the things you need to know. Okay, so first thing you need to know is when the treasurer's position's x is greater than mine, then I need to move west, right? Mm-hmm. That makes sense because it's the same thing that's happening over here. And then we're gonna say move west, and what move west does is it says, okay, then go ahead and update my position to make the x variable 1 greater. So now the second iteration of the loop, what is my position's x going to be? 1. And so then because my position's x is greater or is less than the treasurer's position x, what's going to happen? It's going to move west again, right? And then, so now the my position x is going to be what? 2. And then on the next iteration, I'm just trying to visually make it a little bit more from your perspective, right? So this is interesting, like code quality stuff right here, right? So we are starting off with looking at my position now as the focal point, not the treasurer's position. And then we're going to put ourselves in reference to the treasure. That's a little bit easier to like wrap your head around cognitively. You guys see that? Because if you did it the other way, it's hard for you to think about, oh man, I'm over here, but this is all from the treasurer's perspective. It's like, yeah, I mean, like you've done this before, I'm sure. Like where you're either in grade school or maybe in college, like you had some task where you had to tell somebody who's blindfolded how to get from point A to point B. And it's really difficult to do, especially when you're standing looking at them and they're coming towards you. But if you're standing right behind them and you're guiding them, it's super easy because you're like, that's from my perspective, I get this. So we're doing the same thing in code. So you want to think about code that way. Mm-hmm. How do I make this in a way that people can cognitively understand what's going on? And in this particular case, the easiest way to do that is let's think about doing this in the real world. Let's make my position the thing everything is relative to. Okay. So, third loop around, it says my position's x is going to be, at that point it'll be 2, which is still less than the treasurer's position x, which is 5, so I'm going to move west again. And then on loop 4, it's going to be 4, which is still less than 5, so we're going to move west again. And then on loop 6, my position's x is going to equal the treasurer position x, so we're going to do nothing. And then we'll do loops 7, 8, 9, and 10, and nothing's going to happen. Okay. What I am going to do at the very bottom of this is I'm going to say console log, or console success. How about this? If my position x equals my position y, or x, or sorry, treasure position x. All right, so you guys really want to see this, right? Mm-hmm. You did it. You guys see why that is? At that point, you're on the same exact spot. Okay, so that's what we're trying to get to. So, in this particular case, are we going to get there?
Yeah, in this case.
In this case, we'll get there. All right, so I'm going to do, just in this function, I'm just going to print out the direction that we're moving on each step. All right, just so we can watch it happen. So there's 5 W's. Oh, constant success is anything. All right. So there's 5 W's. right? That means on the first 5 iterations of this loop, it did move W. And then from that point forward, it says you did it. You made it there. And it keeps doing it over and over again. Why are there 6 you did it's?
10.
Yeah.
You get it on iteration 5.
Yeah.
6, 7, 8, 9, 10.
Yeah.
Okay.
So it keeps going because we're not breaking out of the loop. So it still does iterations 6, 7, 8, 9, 10, right? And so it's going to say you did it every one of those times. Okay. So really what we want to do is say break out of this once we get to that point, right? We no longer want to continue the loop. So now we say, okay, once we get there, stop running. Thor, you're running in circles, man. You're not moving anywhere, right? So let's just stop, okay? So, but we weren't breaking out of it before, so it was continuing the iterations of the loop. Just to show that happening, let's just put a debugger in. All right, so right now, I is what?
0.
I is 0, okay? My position X is 0, and the treasure position X is 5. Okay, so my position is less. My position's X is still less than the treasure's position X, so I'm going to move west. Okay, so I'm going to do that, and I'm going to click Go. That prints out west because we moved 1. So now we're on the second iteration of the loop. So now if I look at I, it's going to be 1. My position, treasure position hasn't changed. My position's X is 1. Okay, and then I can click Go, and we'll go to the next iteration of the loop. We went west. I know this is slow, but it's useful, I think, to push through. You guys see that? What's happening? Okay. So that's all we're doing. So that's great. So that works wonderfully when our treasure is exactly west of where we are. But let's try to make this a little bit more complicated. So now, what if we start at position 5 and the treasure's position is at position 1? How do we do with that? So we need to go east now. So how do we make it go east when? How does the computer know it needs to go east? Say that again.
You change like both the directions to east.
Change both the directions to east. Ah, okay. But so instead of being let's do that first just so you can see. Okay, that's fine. So this needs to be east and this needs to be east. Are we going to move east?
We still have to change like the my position by X and treasure position by X.
What?
So it would be the other way around, like greater.
This needs to be greater than? Okay. And what else? I mean, I know I told you not to care about it, but there's one more thing. So right now, if the direction is east, my position's X increases by 1. Is that what I would want? Oh, I'm an idiot, though. Why did I draw that way? Yes. I was like, that is east.
Positioning.
Yeah, positioning is important. All right, let's do this the right way. Yeah, so... All right. So in this case, if I do this, let's see what happens. We move east, it says 10 times, but we never got a success. And it's really because, I mean, I'm moving the right direction now, but really now we actually want to be moving west, right? So if I put this stuff back, and then we'll try this again. Okay. So if my position's X is greater than the treasurer's position's X, and so I'm further east than it is, and I want to move west, which means that I actually want to subtract 1. There we go. So that's where we were before. We were just a little confused about what direction east and west are. All right, so now if I want to do east, I can reverse all of those things. Right? So I could do east, east, versus this, plus this, make this 1 or something less than what this is. And now I'm going to move east a bunch, and I'm going to get there. That's great. But what if so I know exactly what this is because I'm explicitly telling you guys what my position and treasure position are. But imagine you don't know. Imagine you know that it's going to be something that has an x coordinate and a y coordinate for each one of them, but you don't know what those coordinates are going to be. How do I determine when I first get started whether I need to move east or west? So right now, so we did east, and then we did west, and then we did east again. But when I go to run this code, I'm not actually going to know what's happening. Imagine that like you're blind to the things I have highlighted. You just know that there's going to be a my position and a treasure position, and that they're going to have an x and y coordinate. But you don't know if you need to move east or west on the first step. What's that? If else statements. So what's the else statement that I need to add in here?
Like where the cursor is?
Oh yeah, where my cursor
Oh,
is.
it would be else a.
So move west, and then I'll add. Right? So now it doesn't matter if I'm east or west, it's going to get us there. So if I switch my position relative to, see that? So if I switch my position relative to the treasure position, east or west of it, I'm going to end up in the right spot. That's great. So, but now, what if, so let's just, to make it simple, I'm going to start out at 0, 0, so I'm all the way at the southwest corner of things. But I'm going to make the position x equals 5, y equals 2. Okay, so in other words, I'm here, and my hammer is here. So how do I get from here to there? So what's going to happen right now if I run this?
So X is indeed less than the treasure position, so it'll move to the treasure. It'll move west 5 points.
Well, so x is, my position's x is what relative to the treasurer's position x? So this is me. This is the treasure.
Mm.
What's my x relative to the treasurer's position's x? It's less than. So I'm going to move what direction?
East.
East.
Oh, that is east.
So I'm going to move 1 east, and then on the next round, is my position's x less than the treasurer's position x?
Yeah.
So I'm going to move east,
Mm-hmm.
and then I'm going to do it again,
Yeah.
and then I'm going to do it again,
Yeah. That's just fine.
and then what am I going to do?
That's it now, because that's all we got.
That's it now, because that's all we got.
You don't have
So I'm going to get to the treasure.
You're not.
I'm not.
You're not. You're not.
I'm
Let's
not.
go over here.
I'm not. That's right. So how do I get to the treasure?
we can do anything for lives. Like that if I was statements for lives.
Yep. So what would those be? So imagine I just like east and E and W move east and west. We want to move S and N to get north and south. So how do I do? How?
My position or L. We do use L.
I don't care. What do you want to do? Okay.
Position dot y is less than treasure position.
Don't want to do what?
You move. So.
No, stop looking. Man, not help me. I'm just confused with my weird hands. I'm sorry. I was trying to say.
So let's think about this for a second.
We're low.
In this case, my position's y is what? The treasure's position y is what?
2.
Which direction do I want to move? North. So is my position's y less than or greater than the treasure's position?
It's less.
It's less than.
So if it's less, you move up. North.
So yeah. So if it's less, you move up or north. Yeah. I mean, I can't make fun of you. I put east and west on the wrong side. So, all right. So just to get us clear on how to do the problem, it doesn't really matter because we'd figure it out because we'd be able to watch and see if it worked or not and get from there. But okay, so that's going to move us north. So in this condition, are we going to make it to the right place?
Yes.
Yeah.
So I'm just going to put out so on each iteration, I'm just going to put out my position so we can watch like how we move. Okay.
We didn't change the north function.
Now we don't have a north. I need to change. Yeah. And just so you can become familiar, we've seen that. That should do the same thing. All right. So we first move, we go east, then we go east again, then we go east again, we go east again, then we go north, then we go north, and then we did it. Okay? We're running out of power here. So we only have 10 steps. It's our power. We got 1, 2, 3, 4, 5, 6, 7 of them used up. It's maybe not the most efficient way to get there, especially because we can move diagonally. But we'll come back to that in a minute. We did it. It works. This is the most important thing, right? Like we've talked about this, right? Okay, most important thing. It works. All right. So now, though, what if I start high up? Let's leave x alone for the moment, just so. Let's make our y 10. All right. So now I have to go south, right? So how do I tell the computer to do that? What are we missing here?
Let's use the same if else previously. Switch the sign and then our parameter for the move function will be a capital S.
And then
Yeah, we need to add that too.
All right, so we're going to make it to the treasure?
Yes, we will. Not efficiently, but we will.
Yeah, so we did it. Not particularly efficiently, but we did it. All right, so now let's move ourselves a little bit further away. So it'll take us 5 steps to get to x, and right now it takes us 3 steps to get south to y. Do that, we're at exactly 10. Right? So we would go 5 west and then 5 south. So, am I make it?
We just make it?
We just make it. Alright, so now I'm just going to make one more. So we should definitely be able to make it, but we're not making it. We ran out of power.
Oh, man.
So we can even like, if I is 9, Womp, womp, womp. Game over. Okay. By the way, like, we're building a game, right? Like, this could be a game. You can see how this would pretty easily. We add some buttons in where you click on some stuff and whatever, and you run out of power, and it could be a game. Okay, so like just to give you guys, in like an hour, we're building a very simple game. Okay, boom, no more power, game over. All right.
Damn.
So, what do we need to do?
Get that diagonal going. If we don't want to, because the way it was going to evaluate, we should put those diagonals before our regular east, west, north, and south. Because we'd rather take a diagonal than just a simple, left and
Yep.
right or up and down.
Okay.
Or can use and statements.
Can you use and statements? Yep.
So for like the first one, we'll be comparing like if both the my position X is less than the treasure position and the my position Y is less than the treasure's Y position, I believe that is a northeast move. And then we have one of our four cardinal directions. And then
Yeah.
we need to do that for all combinations.
Don't worry about this. I'm just trying to make my own life easier. I mean, you might be able to learn something from this that you could apply, but I'm not so concerned about that.
Is includes an array function or list.
So includes, so strings in JavaScript are actually arrays. They're arrays of characters. Each character is an item in the array. So when you do something like this, it's just looking to see if that character exists. All right, so that's going to move us northeast. In our case, we actually want to go which direction? So we're at 0, 6.
Oh.
So we're here, and our treasure is at 5, 0. So it's here. So which direction do we want to go?
North, south. Whoa, north, south.
We want
Southeast.
Yeah. We want to go north, south. I mean, eventually we end up where we're just there. All right, so we want to go southeast. So this is a fine function, but it's not going to get us where we want to go, so nothing interesting is going to happen there. So how do I write the southeast function?
All right. Now, southeast is when our y is greater than the treasure's y, and the treasure's x is greater than our x.
Yeah, so I'm just to cheat. If I want to go southeast, I'm going to go right, because those are the two for south and east. Right, so if I need to move south and east, then
Well,
that's what.
totally done.
Yeah, and I'm going to move southeast. Okay, so that should move us in the right direction. Now, what's going to happen if we run this right now?
Well, I guess we might get the rest. Well, right now, um, we're gonna move twice as much as we want to. Or
Yeah. So
we're
let's.
not gonna move.
So hold on. So let's just bring everybody in on that. You're right. Let's do this slowly. So on step 1, I is 0. My current position is x is 0, y is 6, right? So I get to line 26, and I say, okay, is my x position less than the treasurer's x position? And is my y position less than the treasurer's y position? No. Is my y position greater than the treasurer's y position? Line 28. So is my y position greater than the treasurer's y position?
Yes.
And is my x less than the treasurer's x? Yes. Right?
Yeah.
So we're going to move southeast. We drop into line 29. Okay, now I continue. So line 31, there's nothing there. Line 32. Is my position's x less than the treasurer's position x? So I'm going to move east. So I've already moved southeast. I'm going to move east again. So how do we stop that from happening?
Just add a continue. Or you could just do an else, or you could add continues to each to 27 and 29.
Yep. So you can do an else if like that, or you could add a continue underneath of here. Continue just says just jump to the next iteration. Okay. So it says don't do anything below me, just go to the next iteration, start over again from the top. Okay. Well, we don't need to do that. We'll just do this much more
So
straightforward.
it's just a bunch of else if statements.
So it's just a bunch of else if statements. And this technically is going to work, right? So we'll get there. We did it. Okay. We can write better code, but we did it. All right. So now, so long as it's east of us, we should end up there, right? So if I change my y and make it so that the treasure is north of me, I should still get there, right? All right. But if I change the x positions out, so I swapped the x position so that now I am east of the treasure. But it's going to take me 11 steps to get there. Am I going to make it? Because we'll run out of steps, right? So just to prove that, we'll run out of steps. All right, so how do I get there? What are we missing? So we can move
We used to go west.
northwest. So how do we move northwest?
We used to add another else if.
Yep.
You just copy.
Yep, we can just copy north and west, right? It's north and it's west. Then move northwest. All right, and then you guys see where this is going, right? So then you do the same thing for southwest. So now everything's gonna work all the time, and that's cool. What's up, Ben?
Sorry, I thought it started at 1.
Sorry, that's just on Tuesdays because Sky has a
Okay.
yeah.
Gotcha.
But it's all online. It's all on OBS. It's available to you. It's all on YouTube, so
Okay.
you can go back and check it out. Okay, so but now it'll all work, but this is not the best code. All right, so pay attention because I want to do the simple version. So to simplify this, there's a couple of things that we could do. There's several ways that I've seen people solve this. I think the simplest is more or less what you saw me doing earlier. You're really just making a decision of east and west and also a decision of north and south. Like you said before, we're going to move twice when we had it set up without the else ifs. So what's going to happen in this scenario? Well, let's start at step 1. So in step 1, we're going to get to line 26. and it's going to say my position's X is less than the treasurer's position X. Is that true?
Oh, my
Care.
position.
No, it's
Yeah.
great.
It's greater than. So I'm going to go
West.
west. And then we're going to continue going. So it's going to say is my position's Y less than the treasurer's position's Y?
Yes,
Yes. So I'm going to go north. So I've already moved east
west.
or west, and now I'm going to move north. Okay? So I'm moving northwest. So did it, right? So I did a diagonal without having to do the end of all those extra lines of code that we had before. Now we could do something that may even get a little bit fancier. I mean, it's more or less the same, I guess. An alternative way to do this, same concept, is you say, I mean, and honestly, the else ifs, they always, because they're written as the exact opposite of each other. We don't need to do the else ifs because we want to make as many moves as we need to. Like, it'll never execute both this line of code and this line of code. You guys see that? There's no way for us to do this and this because this is the exact opposite of this. They're
Are you
mutually
sure?
exclusive. 100%.
All right, because move is
How-
changing our position, right?
Oh, that's true.
So then
That's a good point.
it
Yeah,
could
so
go
you
back
could
over
end up
there.
in a bad position.
Well, it wouldn't go back. It would just go backwards.
Yep. But the point of that is we want to simplify this a bit. We could do something like that, right? Just a little less code.
But
Nah.
what if you're on?
Yeah. What if you don't?
What if you're
yeah.
on the treasure? Then it's going to move you off of the treasure.
Because
Ah,
you gotta
that's
do
a good
the-
point.
you
That's
gotta
a very
do
good
east to
point.
west.
Good catch. Good catch. All right, so let's leave it back there. The thing that I was actually trying to get to is none of this anyway. What I'm trying to get to, what I was trying to get to is you could do something, and actually this would solve some of the problems that we're running into. I could create a variable called direction, and I could make it a blank string. And then depending on what happens, so if I end up here,
Um,
all right, and I'm just gonna move this up just so it's more readable, but it would do the same thing the way I wrote the code. But we could do that, and then what do I want to put at the bottom down here?
Move with our direction.
See that? So that plus equals is doing concatenation. We did a little bit of string concatenation yesterday. It's basically going to say start with a blank direction and then add north. So if we get to line 27, it'll just be N. And then if we add east, it'll become NE. If we add west, it'll become NW, etc. So then the direction is it's just a little simpler way to go through this. More or less does the same thing. You see that? Cool. All right. So this experiment game that we created, practice problem, whatever. This is the example. This is the coding test that we typically give to junior devs when they first come on. What we find most of the time is that they go through the exact same iterations that you guys did. So they start with the if else's. Here's the thing though. I'm gonna give you guys some like life career advice on this type of thing.